What does it mean?
The response is passing through the origin.
This is not response. Actually, this is the x dot versus x. This is not x versus t.
Trajectory.
So second one is stable.
Second one is stable. First one is unstable. But how did you
So
say that?
as the state x progresses, its rate of change goes on increasing in the first curve, but in the second curve, with x increasing, the rate of change of x decreases. So x would decrease at some point. Reduce to a stable value at some point.
Right. This point we have to explain in layman's term. Very good, Sushotam. But we have to. Can you explain in a layman's term? अतएव ये टेक्निक तो मतलब तुम्हें पता था.
So first differential is.
इसका mathematically first of all how can we write? That is for a system. I mean for a scalar differential. Yes. For a scalar differential equation, if x dot into x, if it is less than 0 for all x not equals to 0, then it will give you asymptotic stability. First of all, you tell me whether everybody agrees with this or not. X dot into x. If it is strictly negative for all non-zero s, then it will imply asymptotic stability. Please remember, this technique works only for scalar differential equation. That's what you wanted to mean, right? But now we have to understand, that is, why does it work? How? That means the technique we have just learned, but how does it work and why does it work? That we'll have to learn, right? So that's why I drew these two examples. I'm going to explain, don't worry.
How can we be sure that the state is increasing now? Like we can go from 0 to 2, but otherwise we can go from 0 to minus 2 also. Then it will be.
Yes.
So in the first response, x dot is positive and x also positive. And on the second response, x dot is positive but x is negative. So then it's for the in case of second response, it's satisfying this condition.
ना सिर्फ इसके बाद ही हम लोग नहीं कह सकते हैं asymptotically stable. इसका जो लॉजिक होगा वो एक्सप्लेन मतलब वही पता करना पड़ेगा. Just I try to give you a physical example. So